Hi everyone, it's Onno. Good to see you again. I made a little video of NF Hackathon 2 that took place this weekend in San Francisco. So all the time I did not record video. I was actually working on my own hacks, and that's why you will see large gaps. But I hope it's gonna give you a little bit of the atmosphere there. And I really think that these types of events should take place more often. It's a really great addition to the traditional conferences that happen around rare diseases. And it's much more creative. It's time to build, to think, and to brainstorm together. Everybody's in the same room the whole weekend. So people actually went on till 5 o'clock in the morning. Very excited, and I love the concept of using these hackathons for a good purpose, like solving rare diseases. And yeah, I hope to see more of them in the future. So yeah, without further ado, here's the video. So today is the start of another hackathon, and we are again in a Google Launchpad space. It's different than last time. But I'm excited to see what's going to happen this weekend. And we are expecting about 80 people in the space constantly. So let's see. We are gearing up for the opening talks, allowing people 5 more minutes to come in, find parking outside, which is hard downtown San Francisco, but then we are about to start.
I'm really inspired that all of you decided to spend your weekend here with us working on NF. That is absolutely fantastic. You should all be proud of yourself as morally superior people to other human beings. That's awesome. So
proliferation. So that's where it's very difficult to point out to a single target, because there are so many potential targets downstream of few clinical trials that have been conducted in NF.
Tumors, the low-grade gliomas, the neurofibrosis.
Should be able to develop drugs for these targets, and some of the drugs actually are in clinical trials and working. So the compound into the clinic, it just didn't work. So even though we have these beautiful pathways, and it looks really good on paper, in practice, it's just the drugs don't work when it comes to clinic.
Original scannings may not be cover the entire tumors. So in the clinical, we're using whole body MR to scan the patient and the patients.
if you do at least basic coding, keep your hand up. If you're a woman, don't put your hand down. You typically code better than you think you do. So all of you have a cell phone, so you can check out the Synapse Wiki on this if you're hunting for a team. Who's next? Team leads.
Everybody should please post more.
To be able to move the chairs however we want. Tomorrow, 8 people.
So they are doing team building right now. So the people without a team, they are getting matched with the people that have an idea, the team leads. So that's what's going on right now.
So please try to be out the door by 11, and also clean up stuff. I need to clean up my plate. It's my problem.
It was a good start. It's quite exciting, and to see all the people in the same room. I'm checking out for today. I'm so tired. But it was a good start, and I'm looking forward to tomorrow. I have been hacking today like crazy. It was really interesting. I've learned a lot again, but it's great that the researchers are there, the data people are there. It's just no agenda, hack away, get creative with the data that is available, but also, just as important, maybe more important, the knowledge and experience of the people that are present. So I thought it was really interesting compared to a regular conference where there is a big agenda and there is little time to talk to each other, let alone build anything. This is more like a working session where you're sitting there and you can't help but just build something new and experiment with new ideas, and I think it's amazing. But I wasn't really planning to code myself, but I decided to. I was involved in discussion, and I'm working on drug screening data and trying to find combination therapies, because it turns out one drug doesn't just do one particular thing. I'm trying to combine different data and find new drug candidates, and there is a man present that screens drugs. That's what he does, and I've worked with him on this idea, and he already told me that he's gonna screen the drugs that come out of this. So it's exciting and it's exhausting, and I wanted to work out. I have my gym clothes here, but didn't realize it is a Sunday and the gym is closed after 8 o'clock, and it's 9 o'clock, and so I don't know. I think I'm going home, work a bit more from there, and then get back to the group tomorrow morning.
Genes targeted by the best performing drugs, and try to link it with any information that could be useful in the whole genome sequencing or the RNA sequencing data. So I'll just bring more drugs.
And we're trying to segment basically trying to segment the tumor tissue or not. We did this on 64 by 64 patches of data. Say that the network does something that is.
To summarize to begin with what we found, what we were trying to do was combine the RNA-seq, which is a data set of gene expression levels in a bunch of different tumor types.
And so we took a look at the current data sets that are available at this time. Are interesting pathways. So in addition to the kinds of related pathways, we also found some that.
So I came in here, I wanted to look at MRI images and analyze them, but I was inspired by my old project.
And now we have team Kaiji. Did they make it back in here? Yes, they did.
Differentiate between the different tumor types. So let me just jump to some of these results here. We basically took 4 steps. First, we tried to cluster the RNA-seq data using PCA and TISNE. So that was nice.
For the past decade, research has revealed.
Another pretty crazy weekend. I don't know how many teams there were, 10 I think, and the quality of the presentations was really, really high. I ended up participating myself, which was also a lot of fun. All the professors were here. I could basically talk to them all weekend, and as I mentioned, it's so different from a conference setting. Because here we're just creative and we're just trying to problem solve. No other agenda. You hang out together, talk about all the possibilities. Technology meets molecular biology, and it's just really great. And I'm definitely going to continue with the stuff I've been working on as well, because I'm excited about it. So everybody is now kind of, I think, waiting for the jury. So the judging, it doesn't really matter. People are not here to necessarily win. They're here to make a difference, to explore, to learn, and that's the goal of the event. But I don't know, it just really opens a world of possibilities to have the people from those different disciplines that normally don't see each other sitting in the same room. So in terms of what I personally worked on, I got obsessed by building a drug prediction algorithm based on the data that was available, data that's available online, predicting combination therapies or molecules based on not the primary target of the molecule, but on what really happens in the cell. And there is data available about it. And I managed to create a list with input from the screening data, a top 20 drugs. I'm gonna see if I can build this out so we can do some actual drug screening and see if this approach works. I'll put links to all the presentations on the comments in the video. So if you're interested to learn more, you can just click through.
Yeah, so your face is too far. Tell you your face is too far. Okay.
Press scan?
Yeah, scan. Hold still. Turn to the left. Turn your face to the left.
Oh, turn left?
Yep. Turn to the middle. To the right. Up. Middle.
Down?
Middle, and then down. Down. Oh, it missed the down part, but that's okay.
Okay. Is it? And now it's computing.
Yeah, it is computing. It's uploading to our server and running the model. So you can.
Oh my God.
Yeah. So your hair is
yes.
But it's fine. We can actually go ahead and try this. A better way to do this. We just go to light, directional there. Get a better idea.
So wow, it seems freaky. Like it's pretty cool.
Yeah. So but I think that's because we went a little bit fast. We're trying to add some more hints there. But if you go a little bit slower, you actually.
Can you explain what this is?
Yeah, so we've developed a tool for rapid fire ad hoc phenotypic cutaneous data collection. Essentially, we created an app wherein patients can scan themselves and submit their data to a shared bucket of data with their dermatologist or ontologist or anyone who's viewing their data for them, so that the doctors can both analyze and annotate their data faster and more efficiently, higher accuracy. Patients don't have to report their data themselves, they simply scan it. So we're essentially creating more robust, faster, efficient, and time-saving data analysis pipeline.
That's very cool. Yeah, thanks. And this is the whole team.
Yeah.
Woo.
Hey. Are no function. Hydrogen. Team Stir. And Dermoviz.
What are we doing in Clayton? Too much coffee.
I'm just stretching.
Yeah. This is all the coffee we have left over. I am finally home after the hackathon. I had a really great time. The projects were amazing. The people were amazing. A lot of creative and smart folks in the room. Spending the whole weekend, like full energy. Some people spent the whole night as well to finish their project. Everything is online, open for everybody else to see and to build on. Very inspirational, and thanks at SVAI and Pete and all the other organizers for doing this quite selflessly. A lot of people volunteer for this, the whole SVAI group. So very happy that they're doing this and that the spirit of the hackathon continues. I'm checking out, I'm going to bed, but I'll hope to see you all soon. And I'll post as many of the links and videos and relevant info in the comments of the video. See you later.